Hello, everyone. Welcome to this webinar. Sorry, I need to get my slides first. This is our 33rd webinar. Would you believe it? I'm Pascal. I'm ETP4HPC's communication manager, and my colleague Gabriela is also here to help me run the show. And before I introduce the speakers, I will say a word about ETP4HPC. For those of you who are not familiar with us, we are a non-profit association that promotes European research and innovation in HPC. And we are a private member of the Euro-HPC JU. A couple of practical information for you. So this webinar is recorded and you will receive the link to the recording tomorrow. This webinar is in listen-only mode, but you can use the GoToWebinar control panel to ask questions. You can also download handouts, and the slides are available in this handouts section. You can submit questions at any time during the presentation using the questions panel, and we will share them in the chat so you can see them. But we'll handle all of your questions at the end during the open discussion at the end of the session. So let's introduce our speakers. So we will have first Thomas Guinan. I hope Thomas had a technical problem to connect to the webinar, so I don't know if this is his fault since I started speaking. Not really. Okay. So oh, Thomas, the sound is awful. Please mute yourself. We'll have Utz Uwehaus from HPE. He's head of their HPC AI EMEA Research Lab. And we have Craig Prunty. Thank you, Craig, for being here, because I know it's 2 in the morning for you in the US, so it's really good to have you. And Craig is Vice President of Marketing and Business Development at Cypher, and he's also a member of the ETP4HPC steering board. So you can see your slide,
Okay,
but we can't hear you.
I think I'll get started on the first slide, and
Okay.
Craig does the unmuting.
Oh, the sound is nice and clear. Thank you, Utz Uwe.
Welcome, everyone. As long as my voice carries, I'll be loud and clear. So this is the first topic that was mentioned on Thomas's slides, where ETP ran in this 380 contract with ECMWF, study and discussion with experts around the challenges of federation on the compute and data resources available to destination Earth. And the responsible authors of this are Hans Christian Hopper, who is not with us today, but probably well known to most of you, Craig and myself. And with that, maybe to the next slide. I'll just give the disclaimer, which is this is a presentation based on the work we did, and where the resulting paper is owned by ECMWF. But since we've been working with and for ETP4HPC in this, we're trying to summarize our most important findings to this audience, which is a bit independent of any recommendations we may or may not have made, which we can't discuss in this audience. However, I guess most of you will understand where recommendations would be going, and we'll see how the implementation in this 2-year, 4-year, and more than 4-year horizon is maybe influenced by what we came up with. So next slide is where Craig will take over and tell you the context.
So in terms of the federation, the target for ECMWF and Destination Earth, in fact, is looking at the three, eventually 4 different data centers: the Lumi in Finland, Leonardo in Italy, Mare Nostrum 5 in Spain, and eventually, once it's mounted, the Jupiter system in Jülich. There are multiple other systems that the Euro-HPC actually owns, and they're potentially connectable in a federated system as well. And with this in mind, We came with these existing systems and look at how would we potentially federate them. We talked with each lab to understand the configuration they have, even if some of this is already known, and then what specific challenges would they have in implementing a federated solution. If we look at what we're defining as federation, and this is an important point, it's the act of creating or becoming a union of organizations. So this is not a case where we're designing HPC systems that are going to be federated together. We're not making choices in hardware to simplify the solution or in system to simplify the solution. We're trying to connect systems that exist, which will be the case in, we believe, most desired federation solutions. There's 4 major challenges, and you saw some of this from Thomas's presentation. So first is we have to have an overlay network connecting the different data centers. And we'll talk about some of the challenges we saw here. Second is around identity management. How are users brought to the system? How are they authenticated in the system? The third is code mobility. So you're writing software that's going to run application codes that are going to run. They're going to run on different systems with different hardware by different suppliers in different time frames. So how is that code run on different systems, and what are the implications of that in terms of a federated solution? And finally, the idea of data mobility. You saw in Thomas's slide, there's an idea of or in Thomas's presentation, the idea of a data lake. So now data is held outside of all of the systems, and it's a federated solution for data. And this has some challenges around it as well that we'll discuss.
Okay, so let's look at one way of viewing the specifics of the larger architecture you saw on Thomas's slide. In what we're looking at here, users will face some service platform where whatever a web front end or automated APIs to query data or trigger computation are outward facing. That's not what we are concerned with in this discussion so much. So that's the gray corner in the top right. On top of the core service platform and connectors to the rest, you have your end users. And now end users is a separate discussion for a different round, whether that's people in the general public, decision makers, or scientists that are specially allowed. Not for today, but that's the end user part. But then this core service platform, which manages whatever is decided on access rights, needs a control and a data connection going out into the data lake to inquire about data availability and possibly invoke services, different services that we come to in a moment, of this digital twin. DT is the abbreviation we're using for digital twin here, which could, for example, mean starting specific simulations or moving data obtained in a previous simulation from place A to place B to permanent storage back to more hot storage because it's input data for a new one, all of that. So that's the interactions you have on the control plane and possibly triggering data plane operations. And you have multiple EuroHPC systems in blue. So one here that looks like a classic HPC system, which at the moment we started discussing Destination Earth were essentially general purpose, more research than production HPC platforms. And so each of them comes with their own parallel file system and layout, with their own monitoring solutions, their own scheduling solutions. Luckily, I think most of all the ones we discussed have Slurm as a batch scheduler. So if you're into batch scheduling mode, at least that is compatible. And then you have local authentication, authorization, and accounting per site. And outside of that, you have the data lake, at least with a common metadata schema, but different user identities, service identities that need to be mapped. And so you have gray identities in the user side, whatever the users are. You have green ones in your services, and then you have blue ones on the target. So let's move to the next one and discuss the more detailed one. Craig.
Sure. So here we're talking about, we look at challenges in 3 specific areas. So user management, user policy, how are users authenticated, authorized? What accounting schemes do you use? And I'll talk a little bit about data governance as well, because the data here is coming from outside the system. who has access to it, what are the security concerns around this. Second, we'll talk about the service deployment, orchestration, and scheduling. So everything around the operation of the systems themselves individually and then as a federated solution. So how do we instantiate? How do we schedule local services? That's done today on the local services, but then what do we need to do to unify this in some way? And then the distributed services scheduling. So how is this managed across systems, and how can we make the user experience across systems better? And then the software itself has to be deployed and updated. And then finally, what's the quality of service we're supporting? One of the real challenges we see here is that classically these systems are running users that are prescribed a given amount of time and or nodes, or actually both. Now we're talking about a service-driven model where you may have prioritization and you may have workloads that have to run in a specific time. So it's not just research workloads anymore. The last piece now is system integration. So given that we have different architectures, different hardware, potentially different software that runs on top of this in the existing systems, we have multi-tenancy as a potential solution. How do we manage this in a federated environment?
So let's start from the bottom of this, not because it's the easiest, but it's the one that you heard of last. That's the system integration aspects. The systems as they are available on the EuroHPC overall network are independently executing workloads. They have different architectures, as alluded to. Over time, they're procured at different times. So even if they have components from the same vendors, they will have different versions of the hardware potentially. So different software stacks. And some of them are partially isolated. For example, one of the systems, one of the bigger ones, does not allow contact to the outside from a compute node. Others do. And some allow service identities by default, others don't. So at the same time, these systems are owned by EuroHPC and then some. In the easiest case, by the country government, who paid the other 50% of a EuroHPC 50/50 procurement. Or in a more complicated setting, it could be even only 35% of EuroHPC ownership. And so there's other users, let's call them local tenants, because they may not be allowed to see the destination Earth workloads in reality. They shouldn't know when they've been preempted because their research workloads and the other ones had a deadline. And that creates data pathing issues. How do you separate data? How do you get data in and out of the systems if you have different isolation mechanisms? You have scheduling questions, priorities, guarantees of service. And of course, a workload portability and parameterization issue exist. Even the best programmed workload in a workflow description language will need changes of paths, changes of partition names, and all of that, which is what I call parameterization here. That needs to be transparent so that someone developing a workflow for site A does not need to spend weeks and months porting it to one of the other systems. So that's part of the federation challenge, to provide transparent ways of achieving that. But that kind of assumes portability. So we also need to get the workloads into a state where you can package them up in such a way that they will run at the other side. For the data part, that seems to be the most advanced component already predefined and in existence. That's the Destination Earth Data Bridge that was very small on one of the initial slides of Thomas, which is an ECMWF software solution that is deployed on dedicated hardware at each of the centers participating. So that at least gives a common view onto the Destination Earth data from each compute node. However, even those data bridges will need to address issues on federating them among each other and being part of the data lake. To identify Craig's data from last week is actually in Finland and not in Spain, and I want to continue working on it in Spain. I need policy decisions of whether I move it or whether my compute job should move. The other issue we have on the storage side is access and accounting. Typically, we just look at Unix permission models on our HPC system these days, and on a global shared storage. But we will need guaranteed qualities of service for quality of service on deadline provisioning of data for services. We will need minimum and maximum bandwidth guarantees, minimum because otherwise compute will stall, and maximum because we need to be fair citizens on these systems. And data governance models will be potentially much wider ranging than just easily visible Unix permission models allow you. Think of the fact that you could run maybe a destination Earth analysis, including proprietary country security data and a storm forecast. Now, who owns the resulting data, and how do you deal with this mix of ownership of the input data? Same for commercial users if they become a topic. Who generates data products and who owns these data products, and where can they be stored? Next slide would be Craig.
So here we want to talk about the service deployment and operation. And so we're moving from, as I talked about before, session-based HPC to a service model. Now, along with this comes the idea, as Utz talked about, of prioritization, which is something we don't typically have to deal with in these HPC systems, these particular HPC systems today. So the first point we want to talk about, there's 5 points total. The first is the service interfaces and instantiation. These are not problems that are unsolvable. It's just a question of making decisions. So what service interfaces are exposed, how are they exposed to which users, especially local users, that's already decided, but with federated end users, how are these exposed? Is it shell commands, specific jobs? Again, this isn't a hard question to answer. It's just making a decision and then applying it across the federated solution. And the second would be the user interface. So how do I make the user interface look similar so that if I'm running on one system versus another, does the user need to know this? Do I have a standardized user interface that then is translated to the local user interfaces, and where is that translation done? Again, it's not impossible to do. It's work. It's not necessarily easy work to do, but it's just about making decisions upfront in your federation solution, and you're running on systems that already exist. So you're not designing these solutions for this. You're actually imposing a federation on top of them. Second part is the local service scheduling and orchestration. This really is made more difficult by the idea that there are prioritized work nodes now. So first is, how do schedulers efficiently manage data across multiple nodes? And you have SLAs on top of this now for priority workloads. So you need special mechanisms now. Utz talked a bit about this. So how is data movement managed? What restrictions do we put on resources for a given job? How many nodes are available for a given user? That can be defined, but are there side effects in terms of the architecture itself toward users? We talk about prioritization. Now we can preempt. So I have jobs running. I want to move them, either migrate or freeze them, stop them, maybe even kill them. So the user has to understand that there are given workloads. First of all, how do I manage the data that's been collected so far? If a job's been running for a week and now it needs to be frozen, do I manage the state data? How do I inform the user? What is he given in terms of timing for his job to run and complete? And then finally, the idea of quotas. So we can schedule requests, but a given prioritized job might exceed the quotas that we stated. And then we have to rebalance all of the available resources and the expectations of users. Distributed service scheduling. So here we're talking about service scheduling on the individual systems themselves. And then on top of that, we might have a meta scheduling level that sits at the federated level. So now you have a bi-level scheduling to allow people to run jobs in a single system or across systems. And it may decide which is the most suitable system. But this needs local status knowledge for each center. So what's available, you have to make decisions on what's the expected time to completion for a given system, for a given job, on a given application software. and it may not be different because they're different systems. So now I have to have a way to predict time to completion for these jobs so that I can allocate the proper amount of resources in the proper amount of time. And then if I migrate during this job, which is a possibility, how do I then reallocate and recalculate? Software environment. So we talked a little bit about there are different systems with different code running. So we don't see, if there are different systems, you won't see the same performance for the same kind of workloads on different hardware. You will try and port and optimize to get as close as possible. And you won't even necessarily be running the exact same application code on the different hardware. So there's an exercise here to do the porting and the optimization, and then to understand the deltas for the performance. We have to manage software updates. And again, these are managed locally for the different systems today, and you'd expect the same to be true. But then at the federal level, you also have to manage updates, and you have to align across updates between systems now. You can add containers. This will help in some respects, but you have to first understand the different systems and then align the way that the containerization policy tools and the associated security are managed. So even if we have services that stay within quota, they can impact through shared resources. So I have networks and network interfaces and even network between nodes and even network within the compute elements themselves. And this can be impacted by jobs running on prioritized workloads. And so you may get a slowdown on other jobs. And you may then have to exceed your quota to get a run completed. Longer term, we would implement QoS, quality of service, to guarantee and police and prioritize workloads. And finally, Utz alluded to this. Now I may have private data or even secure data on my given systems. But today, we don't worry about monitoring and observability. So anybody could potentially see any data. Now that I have potentially private data or secure data, I need to understand who can see what data and how do I want to restrict and control this. Finally, for service deployments and updates. So I referenced this a little bit earlier, but local system updates have to be coordinated at the federal level, and federal system updates have to be coordinated down to the local level. You could imagine that somebody doing pushing a software update at the federal level, if there's jobs running, this could cause chaos. And vice versa, if I have some kind of interaction at the local level to federated to federated codes or just plain software stacks, middleware stacks, I have to make sure that everything is aligned in terms of upgrades. Now, eventually, the way that you can manage this is with CI/CD, with continuous integration, continuous deployment. But that's something that's not easy it has to be architected well. It's not easy to implement. And this is being implemented in our case on systems that already are in place. So it's not designed in, it's overlaid. And then there are cases where you have binaries that are distributed, and that is a solution to distribute binaries. But then you have to manage everything centrally, which isn't the case today. Woods?
Yeah. And what we can't manage centrally to the end is users. Now, on the first part, we will have central authentication of what I called end users on the outside, and maybe some sort of nested registration so that you're under the umbrella of think of the same as a project today on HPC. But you may have overlapping roles. I mean, the same people like me being both someone who has a regular Lumi account on Project One, but also may have an account for Destination Earth project that my team is involved in, and then maybe as an HPE employee because it's an HPE system for fixing issues. So the same people may have different roles, and while traditionally that could easily be done by switching project belongings for a moment, we may need an actual role-based system that takes external roles at this interface level of my first diagram into service identities which carry along specific ownerships of can access this data, cannot access that data, has compute time for this purpose, but no GPUs or only GPU jobs. Think of that, and that will stagger, right? Depending on which particular job is running under the service identity, it may perform jobs for Thomas and Craig and me at the same time. So you get intersections and unions of roles, rather complicated system potentially. So it's really important to come up with a policy framework that restricts the number of these service roles to technical aspects and keep the end user clearance on that as far as possible outside of the federation of the HPC systems. In the end, still there may be cases where proprietary access to data will be a one-off flag for each data set that is owned by a different entity. And that goes together with what I mentioned initially, that different sites have their own difficulty of identifying users. We all know that until a few years ago, you had to send faxes to some sites to register. So that's clearly something that needs to be centralized. We have good examples in the European ecosystem of federated IDs for academic users and academic sites, but often that doesn't carry over to other participants. And that's where this AAA, authentication, authorization, accounting, and just in case you're always confused which is which, I put that box on the top right to remind everybody what we're distinguishing here, comes in. In the end, it's performed locally with different solutions for different centers, and we need to make sure that the center requirements, national laws, and common ways of doing it, in particular hosting sites, are well enough aligned with what federated users need, possibly nesting identities, and then figure out a way to make it match. I mentioned most of the items under here already before, which leaves us in the end with a discussion of quality of service, where, again, if you ever talk to an operational data center working for weather and climate, more for weather, of course, they have to have a solution at a specific time point because nothing is less useful than weather predictions for yesterday. So that's not something HPC centers typically deal with. And in all the use cases that talk about disaster recovery or emergency planning during a flood, during a rainstorm, hurricanes, that kind of thing, you need these deadlines. And even if you think about harvest planning, you have not as tight a deadline, but you still have them. That's the maximizing throughput that we currently see versus completion time dilemma, which are typically different objective functions. Monitoring, already mentioned by Craig, is going to be an important part, understanding usage of resources in order to do online rescheduling. If you don't know what the current utilization is, which job has been stalling, you don't know which ones to preempt well. And coordinating this information across centers, just in legal terms, is a difficult thing because some of this data that you collect may be personalized, personal identifiable data, not on the destination or service jobs so much, but on the concurrent users that you're interfering with potentially. And so it's not easy to share that. There need to be anonymization strategies, aggregation strategies that allow this central reasoning and prioritization. We also discussed quality of service on the level of actual performance, like bandwidth limits, and some of those may need nesting. With that, I think we're getting to the end of the 3 challenge regions, and I'll leave it to Craig to do our outlook.
So again, we see this exercise for Destination Earth as having a wider value than just looking at these 3 or 4 systems. The challenges that we see here would exist in many federated solutions, and especially as we potentially scale Europe's federation across all Euro HPC data centers. As mentioned in the beginning, we're looking at different time horizons for the recommendations that we made here In the extreme, you could say that I'm just going to connect these three systems with a network and have a data lake between the three. And going from there, you want to move to a point where the user may not know specifically what nodes or what supercomputer they're running on for their workloads, and you would manage that for them seamlessly. And the recommendations go from sort of the first extreme of a very simple interconnect. That's not simple, but it's, let's say, without and managing everything locally, to the point where everything is managed at the top level, at the federal level. There are other challenges that were addressed for Destination Earth, as Thomas outlined in the beginning. So looking at the data movement, the data streaming, how data is acquired, and looking at some, perhaps even IoT solutions, and having different kinds of data acquisition than classical weather has used. The safety and security, and data and code governance, and finally math and algorithms. And there are different sections and presentations on each of these bullet points as well, in addition to this federation study. So with that, we'd like to thank you for attending this webinar. I will pass back to Pascal.
Yes.
And I believe there's a Q&A session.
Yeah, exactly. So we're waiting for questions. I see we have one already. Let me share my screen. Yeah. Okay. So first question from our friend and colleague Sai. Sai asked, I think addressing quality of service will be extremely tricky in a federation. It's hard enough even for standalone centers, especially for parameters such as BW, bandwidth, I suppose. What kind of parameters for quality of service do you imagine for the users? You can see the questions in the chat that's for attendees and speakers.
Well, let me take a first shot, and then
Yeah.
others can chime
Okay.
in. So, so there's two different types of quality of service that I see. One is the technical one on a system that, if this was Sai's question, Sai is referring to, which is a classic HPC problem. How can I express bandwidth needs or guarantees my code makes or needs at a specific code level? And there we'll see the usual parameters, amount of memory required per node, bandwidth for memory, for storage access, for internode communication. And I think while we don't have good solutions for all of that in all cases, we understand that problem, and it's not an old, it's not a new problem, but it's a problem we see more exaggerated in this federated setup, because whatever solution has been built so far is either built into a specific appliance, let's say a Luster black box that has certain guarantees and site specific, or it ends up being twiddling inside an application. So that brings us to questions like, how can a user, I mean, not end user, but a code developer that writes a code or a workflow, inquire about properties of the system they're running on in a portable way? And we all know HWlog tells us about the CPU type and the DIM type to the last epsilon. That's too fine granular. But that's the kind of information that we need abstractions for. So I can take an inventory when my job starts to say, okay, this is a system like X. I want this or that parameter to be like that. And then we need steering parameters to deal with that in our middlewares. The other entirely different quality of service is the one that Thomas should care about, which is if there's a deadline for a specific simulation, or for a training run of some AI tool, so that can be deployed with the next deployment in remote edge deployments where you only have one chance a month to go out and flash those firmwares with new AI models for decision making, then we have a deadline on the scheduling side across systems, and that's something that both needs SLA level contractual QoS guarantees, and it needs monitoring for this meta scheduling to be effective and find the best place to run a specific job. And that's where the two meet. The job definitions need to have kind of performance benchmark info attached to them so that this meta scheduler can reason about, if I run on system A, it's going to be double the runtime, but then system A is empty. I can get a few extra nodes today. And tomorrow things might look different and we choose system B, where it's awfully fast, but we have 2 hours of queue wait time expected and 5 hours guaranteed latest starting time, because then the system will kick jobs out for us. But I see those two, and yeah, I mean, there's a lot of interesting research, but that's not the 2-year horizon for sure, Sai.
Okay, thank you. No other question. Craig, did you want to add anything, or
No,
is it
I think
okay?
that was
No?
no, that
Okay,
covered.
that was an extensive answer. Okay, any other question? I don't see any other question coming in. I had a small question to both of you. I mean, the ETP4HPC is currently preparing our strategic research agenda, edition 6 of it. And how does your work for this Destination Earth project also feeds maybe your work in this SRA? Because I know you both are involved a lot in the SRA.
Mike, you
I
want to go
think
first?
yeah, sure. So the way that the SRA is structured, there are a number of different elements. So you're looking at systems, you're looking at components. So it breaks the
Mm-hmm.
problem down in a different way. But the challenges for federation can affect all of the different, and in fact, there is a section on federation as well, specifically. So
Okay.
I think it cuts across all of these elements. So if I look at some of the challenges we see here on the hardware side, I have different components in different systems, and that's by design. We're not looking for all HPC systems to look similar. Part of the idea of HPC is research on systems themselves and how can they perform. On this, at the system level, all of the challenges we talked about can apply. So I think it really cuts across the entire SRA. We're talking about cutting edge technology. The other thing that we're seeing in terms of federation is there's something similar in terms of hybrid solutions where you have part of the system on premises and part of the system in the cloud. So we're also looking at applying cloud tools, which are more operational than HPC systems, to across systems in a federated solution. So it's very similar to hybrid solutions where you have part of the solution in the cloud and part of the solution on-prem. Oops,
Okay.
anything?
And
There's
in
so many
fact,
areas this intersects. Yeah.
yeah, and in fact, just going back to that, there is a cloud in Destination Earth, right? That was on the first slides, which is the part around users, user access, and part of the data lake, which is outside of the HPC centers. I just like to repeat what Craig said here. I mean, there's overlap in people, there's overlap in technical interests, and while we've made a specific white paper targeting Destination Earth, the topics have cross-cutting concerns. Not all of them are relevant for our SRA. Don't get us wrong.
Uh-huh.
So it's not like we're just copying one-to-one. Some of the aspects that we have in the SRA are wider and may also come to different decisions than this specific project, which has specific needs, starting from requiring to use these systems as they are today and running specific jobs with specific requirements. On the other hand, math and algorithms working group clearly has some aspects on mathematical aspects that also show up in weather codes.
Okay, so actually we have a message from Sai. So Sai Narasim Hemmerfi, he's our the leader of our SRA effort. So he says, just a note, we plan to have a white paper on federation in the coming weeks and months tied to our strategic research agenda roadmap. Many of these learnings we hope will be of great value here. Stay tuned. Yeah, stay tuned. And actually, for those of you who are interested, the SRA number 6 will be released November, I think. We hope. So indeed, stay tuned, and if you're interested in federation topic and much more in our SRA, I'm sure you'll be interested to have a look at our SRA. So, do we have any other question? I don't. Oh, yes. Okay. Question from Flavio Galeazzo. Which do you think is the most challenging part of the federation? Who takes this one?
This is for Thomas.
Okay. But can we hear Thomas?
No,
No?
I can put words
Oh,
in
yeah.
his mouth.
Yes, it's working. It's not too horrible. But I think the
So,
federation does. Yeah, it's not working. Sorry.
Okay, so I'll take a step, and then Thomas shakes his head or nods. I think in the end, it's federation is something that needs to be done between existing organizations and existing systems. So it's people, it's existing legal contracts, frameworks, existing hardware, software constraints. All of the individual items that we highlight can probably be addressed in a technical fashion, one after the other. That needs to fit, and you need to come to decisions which are mutual agreements. You cannot force anything here. I think that's the hard part.
okay. Thank you. Thank you for this answer. So I don't see any other questions. So I think we will close our webinar maybe. So I would like to thank our speakers today. Thank you to Craig, Uwe, and Thomas. This webinar has been recorded, so we'll send you the link tomorrow. So if you want to share it with someone or listen to it again, you'll have the link. Our next webinar is in October, on the 18th of October, and it will be again about the DE380 project, but two new topics about IoT and networking and about data streaming. So if you're interested in those subjects, do register for our October webinar. So yeah, I'm checking again. No new question coming in. So yeah, we will definitely close the webinar now. Thank you to our audience. Thank you to our speakers, and I hope no, I'm not hoping to talk to you in October because I'll be on holidays. It will be Gabriela who will be in charge in October. So bye bye everyone.
Bye bye. See you in